We have discussed about the net force already in the previous concept. Let me tell you more information about net force. Net force concept comes when you have more number of forces on a given body. See, this is a table. This table on the floor. Now, a person standing on the floor and applying the force. So he's applying the force F1. So with the F1 force, the table moves in the forward direction. Good. Now see the second case. Same table. This time, one person applying the force F1, and another person also applying the force F2. Both are applying the forces. Two persons are applying the forces on the table F1, F2 in the same direction. Then what is the difference between this diagram and that diagram? Don't say the difference is here one person, there are two persons. No. The difference is here only one force is applied, F1. Here two forces applied which are in the same direction, F1 and F2. When the force is applied in the same direction, then the resultant force we can call net force equals to sum of the forces F1 plus F2, because both are acting in the same direction. Take the third case. Same table. So person standing here and applying the force here, and another person standing here applying the force here. This person applying the force F1, that person applying the force F2. What is the difference now? Here also two forces are acting, there also two forces are acting. The difference is here the two forces are opposite to each other. So like this, F1, F2, opposite to each other. The net force, you have to take the difference of the two forces. Difference of the two forces, why I told, if F1 is greater, then you can say F1 minus F2. If F2 is greater, you can say F2 minus F1, because you have to subtract the value from the bigger value. So here F1 minus F2, because I understand that F1 is greater than F2. So in that way, whenever many forces are acting, you have to take the resultant force, and the resultant force is called net force. Now take another example. There is a car. There's a car in motion on a road. Generally, you know that car is moving because of the engine. Engine apply the force on the car in the forward direction. Yes, it's moving. Now think there is another force acting between the wheels of the car and the road. What is that force? We studied earlier. Got it? That is friction. Friction force. So when I said this friction force, then I can't say that car is having the force of F, capital F. No, the car is having two forces, capital F and small f. Therefore, the car's net force equals to capital F minus small f. Why do not write capital F plus a small f? Because both the forces are not in same direction, they are opposite direction. That's why minus sign. Now second point, why I haven't write small f minus capital F? Because capital F is greater than small f. I told earlier here, which force is greater, you take that force first. So as the capital F is greater, so I wrote F minus small f. So that is how the net forces you have to take. Take another example for your better understanding. This is the first example, this is the second example. Take the third example. There is an elevator. Elevator, you know elevator. Elevator means lift. This elevator, inside the elevator, a person is standing. And elevator is moving in the upward direction. In the elevator also many forces are acting. One is the person's weight. Person's weight plus elevator weight acting downward direction. Because of that, it has to fall onto the ground. But it's not falling, it's moving up. Why it is moving up? Because there is a applied force by the machine, elevator machine. That elevator machine making the lift to move up. So that force acting upward direction, this force is greater than this force. So the F1, this is F2. So F2 is greater than F1. That's why elevator is moving up. Now another point I will tell you. If these two forces are, okay, two forces are opposite, but two forces are equal and opposite, what happens? Then the net force acting on the body is 0. Because two forces are equal, net force is nothing but F1 minus F2. When both are equal, the resultant is 0. No force acting on the body. When no force acting on the body, then the body or the elevator moves with constant speed. But generally, it won't happen. No elevators will move with constant speeds. That's why when you're standing in the elevator or lift, you feel that you are moving up or going down, or some jerks you feel, because they are not moving with constant speeds. Why they are not moving with constant speeds? Because these two forces are not equal. Generally, F2 force will be greater than F1 force. F2 force is greater than F1. Therefore, net force is F2 minus F1. When the net force is existing, then this elevator doesn't move with the constant speed. It moves with different speeds. That's why we say elevators moves with non-uniform speed. Non-uniform speed means not a constant speed. When we understand that many forces acting the body, we have to take the net force. We should know that what are those many forces are acting on the body. We have to visualize the forces acting on the body. How do we visualize? By drawing the diagrams. So in physics, whenever you want to know the many number of forces are acting and how they're acting, which direction acting, you are allowed to draw the diagrams. And those diagrams are famously called as free body diagrams. Let me draw here and tell you what the free body diagram means. See, take a car, is on the ground, is on the road, say the car is moving. Now I ask you that show me all the forces acting on the car. And when you are able to show all the forces acting on the car, it will become free body diagram. The first force is capital F, applied force because of engine. So this is F, say this is, I'll write applied force, F equal to applied force, or external force also you can say. Now between the wheels and the road, you have frictional force, friction. That's it. Anything left? Just think there's another force acting at the point of contacts. Yes, that force is normal force, N, both are normal forces because of 2 point of contacts. So how many forces we have identified? Applied force, normal force, frictional force. That's it. Only these forces, we do not have any other forces? Yes, we have another force. This car moving in the air, and air is coming like this. When air is coming like this, because of air also some force opposing the motion of the car, and that force is air friction, air resistance also we can say. So this is what called free body diagram. So by visualizing, drawing and locating all the forces on the diagram is called free body diagram. This is the first example. Now take second one. Take the example of aeroplane. Aeroplane or rocket, anything you can take. So this is flying in the air. Now I ask you to show all the forces acting on it. First thing is, it is having weight acting downward direction. Weight is acting downward direction. As moving, suppose it is moving in this direction, so forward direction it has force, applied force. And this side you have the air, so you have air friction, F. You have air friction, you have forward force, you have weight. Because of weight, this rocket has to fall, or airplane has to fall, but it's not falling because there is another force acting which is called lift. Lift force. Air lift, it pushes up. And that's all. That was the forces. So in that we have to imagine how many types of forces acting on it. Come back to previous example. Here one force we have missed. Can you guess? By observing these forces, can you guess which force we have forgot here? Yes, you are correct. The weight of the car. Weight of the car acting downwards. So that you take any diagram and try to draw all the forces what you know, and that will become free body diagram. And these are very much helpful for you when you go to grade 9 and grade 10, and when you appearing for competitive examinations in physics. Right. Whenever you are telling about the force, you should tell that what is the force value and what is the direction of the force. Why? Because force is a vector. Vector means what? Vector is a physical quantity which is having magnitude and direction. Generally in mathematics we will discuss these things, vector and scalar, and those mathematical things are very important in physics also. Scalar means is having only magnitude, like mass. Mass is a scalar. You no need to tell that what is the direction of mass. Time is a scalar, having only magnitude. No need to tell what is the direction of time. Say mass equal to 20 kg, that's it, 20 kg is the magnitude. If I write here mass, m equal to 20 kg. This 20 kg is called magnitude. Then no need to tell the direction, enough. If I say time, t equal to 2 seconds, this 2 seconds is called magnitude. No need to tell the direction of the time. But force is not like that. Force is a vector. Vector means it is having magnitude and direction, both. Say I have taken a box M and I have applied the force F. If I say like that, I am not completely gave the information to you. I have to tell that I have taken a mass M equal to 2 kg. 2 kg mass I have taken, and I have applied force F equal to 3 newtons. See, a new word I introduced, Newton. What is Newton? Newton is the scientist name, famous scientist name, and his name taken as a unit for the force. Like how the mass unit is kg, how the time unit is seconds, force unit is Newton, capital N. So 3 Newton, when I told, 3 becomes the magnitude. Then what is the direction? Yes, the direction is towards right. Or else you can say, you can take the directions like this: east, west, north, south. And you say that the force is acting towards east. Take another example. Now this time, same mass 2 kg. Now 2 forces are applied. See carefully. 2 forces are applied. F1 equal to 2 newtons. F2 equal to 3 newtons. Now what is the force direction? Now they should be careful because 2 forces are there and you have to check whether the directions are same or opposite. As the directions are in the same direction, all the 2 arrows in the same direction, you can say the resultant force F equal to F1 plus F2, which is 5 newtons. So the magnitude of the resultant force, this is also called net force, is 5 Newton. Now what is the direction? As the two forces are in the same direction, you can say it is towards right or towards east. So direction is east. Suppose if you take the third example like this, you take the mass m equal to 2 kg again, and the force F1 equal to 3 newtons now, and F2 equal to 1 newton. Now, if you when you have many forces I told you earlier, you have taken net force. Now, which force is greater? F1. So it is F1 minus F2, which is 3 minus 1, 2 newtons. So the magnitude of net force is 2 newton. Now, what is the direction? The direction will be the direction of greater force. And here the greater force is 3 newton. So it is also towards east. So far we have learned with different types of forces and how to calculate the force, how to represent the forces using free body diagrams. Now see the next one, effects of force. Once a force acts on a body, what happened to the body? So many changes happen to the body, and these are what called effects of force. Number one, changes direction of motion. Yes, change the direction of motion, obviously. When the ball on the football ground coming towards you, and meanwhile one person hit the ball towards left, then automatically the motion of the ball changes and goes towards left. When he hits the ball, is nothing but he is applying the force. So force changes the direction of motion. Force changes state of a body. The ball on the football ground is a rest state, and when you hit on it, it comes into motion. Suppose the ball is in the motion and you catch the ball, and immediately the ball comes to stop. So in both the cases you are applying the force. In the first case you apply the muscular force using your leg. Second case use the muscular force using your hands. So in that way you can change the state of your body. Next, changes speed. Yes, of course it changes speed. When you apply the force, see in the previous example I told the car is moving on the road because of friction. If friction is more, car speed decreases. If friction is less, car speed increases. So in that way force changes the speed. Force changes shape of a body. It is true. Take an inflated balloon and you press the balloon, then you see you can change the shape. Take a sponge, press it, you can change the shape. So in that way force can have these type of changes. Do you understand that when you carry your school bags, the strips of the school bags, if you observe, the strip will be wider. Suppose you are carrying the school bag, keeping the strip on the shoulder. See the strip width, it's wider. Why the strip size is wider? Do you think that when you see the trucks, the loaded trucks especially, if you see the rear wheels, you can see the rear wheels number is more comparing to the front wheels. Maybe the front wheels are 2, but rear wheels may be 4, rear wheels may be 6. Why it is like that? If you see a drawing pin, the drawing pin head is wider and the tail is sharper. Why it is like that? There is any concept behind it? Yes, in all this example there is a concept behind that. The concept is pressure. What is pressure? Pressure is force acting on unit area. Force acting on unit area, or simply F by A. So pressure is force only, but especially that force acting on unit area. Suppose you have taken a plank like this. The plank, you have taken plank. This plank has length L, breadth B. and you have applied force like this, and I asked you what is the pressure applied, yes, you can tell the answer. The pressure P equals to force by area. So area of the plank is a rectangular plank, so you can say length into breadth. P equal to F by L into B. Say if the force is 2 newtons, length is 1 meter, say length is we can say 0.5 meter and breadth is 0.2 meters. Then what is the pressure? Pressure P equals to F by L into B. Na? So 2 newtons by L is 0.5 meter into breadth 0.2 meter, which is equals to 2 newtons by 5 into 2 is 10, but 2 decimals are there, so it is nothing but 0. So you have 10, so 2 decimals, so 0.1 meter into meter square. So the ultimate last answer is 20 Newton per meter square. So that is the pressure acting on the plank. And in this example, surprisingly, we got the unit of pressure, and unit of pressure is Newton per meter square. So unit of pressure, you can write Newton per meter square, but many times instead of writing Newton per meter square, we will say Pascal. Pascal is called SI unit of pressure. Why taken Pascal? Because Pascal is a scientist's name. To honor him, we have taken his name as unit for the pressure, Pascal. Okay, now coming back to the example, this example. This drawing pin, the head, if you see, the head is wider, or it has more area of cross section, whereas the tail is sharper. Why they are keeping like that? The only thing is, if you see this formula P equal to F by A, if force is constant, then I can say pressure is proportional to 1 by A. Means pressure is inversely proportional to area. More the area, less the pressure, or less the area, more the pressure. Means when area decreases, pressure increases. When area increases, pressure decreases. That is called inversely proportional relationship. So here what happens, here you have larger area, you have small area. So the larger area, when you apply the force, larger area applied the force, small force F you applied in the larger area. So the pressure will be less here. Means when you press the drawing pin, you want to keep the drawing pin in the cardboard. So when you press on the head with the force F, your pressure is less because area is more. Because area is more, the pressure will be less. But when you go to this point, the same force carried to the pinpoint, this side. But here the area is less. Therefore, pressure will become more. And hence, even though you apply the smaller force, the drawing pin easily pierced into the cardboard. Because less area, more pressure. Take another example of the school bags. If this is a school bag, and the school bags have larger strips like this, the strip width will be larger. The width, this is what I am talking about, width will be large. Why? Because larger strip means area is more. When area is more, what happened to pressure? Pressure is less. That's why when you keep this, the wider strip on your shoulder, you don't feel that amount of pressure on your shoulder. So you can easily carry your bag to, and you can walk on the road, or you can move into the school, in the campus of the school. Now come to the example of truck. Truck, why the truck has 4 wheels on the rear side? Because if they increase the number of wheels, the area occupying the wheels increases. When the area increases, automatically the pressure decreases. That's why they can keep the load on the truck, and even the load on the truck is kept, that load won't be affect the wheels of the truck because of larger area. Okay, so more the area, less the pressure, lesser the area, more the pressure. You may surprise, if you take elephants, if you see the elephant legs, the leg, if you see the width of the foot, area of the foot is very large. The area of the foot is large. We feel that when the elephants are walking on the ground, they will apply huge amount of force on the ground, but actually it's not like that. Because of larger area of the foot, the pressure will be less. So elephants are applying less pressure on the ground. But it may be funny to you. If you see the women's sandals, pinpoint sandals, like in the many times you have seen the pinpoint sandals where you have the pinpoint like this. Generally, women's sandals, the pinpoints they wear. And this is the pinpoint. Here, the area is less. So pressure is more. So if you compare the area, if you compare the pressure applied by this pinpoint sandals and pressure applied by the elephants, I will tell you that this pressure is more than that pressure because their area is more, but here the area is less. So we have learned about force and types of force and fields and pressure. Now let's have a discussion on exercise of this chapter. First question. Give situational examples to the following. Number 1. Changing the speed of an object. Number 2. Changing the shape of an object, changing the direction of an object. So 3 situations are given. You have to give examples. It's very simple. Changing the speed of an object. Give an example. The example is air friction on the car. If more the air friction on the car, automatically car speed decreases. The second one, change the shape of an object. Anything you can give. I told you earlier, take an inflated balloon and press the balloon, automatic shape changes. Change the direction of an object. Say one ball is rolling on the floor and it is rolling towards east. Now you applied force towards south. The immediate ball changes direction and move in different way. So those are the examples for the 3 cases. Next one. There is a diagram. And stick is placed like this. Like this. Now you have to identify the normal forces on this stick. It's a stick. How will you identify the normal forces? You have to show the normal forces there. We discussed that normal force act on the point of contact and perpendicular to it. So the first block, the scale or the stick is point of contact is this. Second block point of contact is this. So normal force acting perpendicular from the point of contact. So it will be like this. This is a normal force. And this is point of contact to this normal. This is normal force. That's it. Go to the next question. How can you differentiate contact force and force at a distance? We have to give 1 or 2 differences for it. Contact force means the body and the source of force should be in contact. So example, muscular force. So this is a muscular force. Friction, the force between my fingers and a chalk piece, the force between wheels of the car and the road, friction, normal. So all these are contact forces. Force at a distance means no need to contact. The source of force and the object should not be in contact. So force at a distance example is magnetic force, gravitational force, correct, and electrostatic force also. Next question, see here, detect the mistake in the statement. Because the car is at rest, no forces are acting on it. Generally, car is at rest means, of course, the net force acting on the car is 0. But still, car has some forces experienced, like the weight acting on the car, acting downwards, weight of the car, and the normal forces acting upward. So the statement can be written, rewrite as, because the car is at rest, net force acting on it is 0. Next one. You have taken 2 straws like this. 2 straws, plastic straws. Straw 1, straw 2. Second straw is rubbed with an inflated balloon for some time. Now bring that rubbed straw 2 near to straw 1, or bring the straw 2, rubbed straw 2 near the paper pieces. What happens? The paper pieces attracted towards the rubbed straw. Why? That is the question. As you know that it is only because of electrostatic force. When this straw 2 is rubbed with the inflated balloon, the straw 2 gets the positive charge over it. Because of positive charge, it attracts the paper pieces towards it. Now second one, you have a comb with the teeth like this. Okay, and again paper pieces. Whenever this comb is combed with the dry hair and keep near the paper pieces are attracted to it. The question is why? What is the answer? Same, because the charges are accumulated. The charges are accumulated on the teeth of the comb and develops electrostatic force. So this force attracts the paper pieces. Next one. Why do tools meant for cutting have sharp edges? This is the question. Take a knife. Knife has sharp edge. Why? Sharp edge. Why? Then if you want to know the answer, then you have to go to the concept called pressure. There we discuss that pressure is inversely proportional to area. Lesser the area, more the pressure. As the edges are sharp, the area is less. When the area is less, pressure is more. Due to that reason, using these knives easily cut the vegetables. Easily cut the vegetables, the same to quickly cut the vegetables. So sharper edge means less area, more pressure. Next one. There is a heavy object and it is applied by force F. Still, body is at rest. Question is why? Why the body is at rest even the force is applied? The answer is, as the body is on the ground, there is a contact force between the body and the ground surface, and the contact force is frictional force. Even the force is applied, body is not moving, because frictional force is greater than applied force. That's why body is not moving. And this frictional force directly proportional to normal. And you see this diagram carefully. From the point of contact, I have drawn the normal, and body weight is acting downwards, mg. It is the weight. So from this diagram, I can say N equal to mg. So more the mass, more N. More the N, more the friction. That means friction depends upon the weight of the body. If weight increases, friction also increases. When friction is increased, then if you want to move the body, your applied force also to be increased. So here applied force is very less, that's why body is not moving. Next one. Find the net force. First one, there is a block. Two forces are acting, 8 Newton, 10 Newton, and another force acting, 12 Newton. Second one, again block. This is 8 Newton, this is also 8 Newton. Third one is a block, 8 Newton, 6 Newton. Now last one, this is 9 Newton, this is 8 Newton. So 4 diagrams are given to you. You have to find the net force. Net force means if the forces are in the same direction, add them. If the forces are opposite direction, subtract them. This is the first one. 8, 10 are same direction. So 8 plus 10. 12 is opposite direction, minus 12. So 8 plus 10, 18, minus 12. This is 6 Newton. So 6 Newton towards east. Direction also you have to specify. Second one, 8 Newton, 8 Newton. Both are same in opposite direction. So net force is 0. 0 Newton. Third one, both the forces the same direction. So 8 plus 6, 14 Newton, again towards east. What's this one? 9 Newton, 8 Newton. 9 minus 8, as they both are opposite direction. So 1 Newton. Which force is greater? 9 Newton upward. So this is greater. So 1 Newton towards north.